Hello. So we like to look at uh, some polynomial distribution from algebra 2 and trigonometry. All right, let's try to get started here. For number 3, x plus y to the sixth power. How are we going to do this? In fact, you will realize that each term will be in form of this n cr, and first term in this case x to the uh, n minus r power, and y to the r power. Now, in other words, the very first term in this case will be equal to n c, or in this case 6c0. That's the beginning portion. Then we're going to have x to the 6 y to the 0 power. This will be very first term. Now, plus the second term becomes 6c1, but another way of writing it would be simply with the parentheses 6c1. This will be the binomial coefficient in a simpler way of writing, so I'm just going to write it in this way. This is the same thing as 6c1. Now, then we have x to the fifth power and y to the first. And we're just going to keep on going like this. 6c2 and x to the fourth and y square, plus next one becomes 6c3 and x to the third and y to the third, plus 6c4, and we have x to the 2 and then y to the fourth. Notice that x goes down by 1 while y goes up by 1. And then we're going to continue with the 6c5, x and then y to the fifth power, plus 6c6 of y to the sixth power. Now, oh yeah, it was kind of long, yes. If you have to look at each and every one, what's going to be happening is this. I'm going to try to do number 8 and number 9 a bit later. This becomes 6c0 is equal to, in fact, 1, so our first term becomes x to the sixth power. Second one becomes times 6. That's how you can get 6c1 with your calculator. 6 and then x to the fifth y, and 6c2 becomes, in fact, 15. So 15 y to the fourth, or x to the fourth and y square. Next one here, we end up getting 20 x cubed y cubed, and then this one is in fact equal to this one. Here we end up getting 15 x squared y to the fourth power, plus this becomes 6xy to the fifth power, and plus here becomes y to the sixth power. And these all coefficients, you guys can do this one by using your calculator. Alright, let's look at number 8. Here we have 2 plus a to the fourth power. Now, I'm going to use a different color to express this one. Here, then first one is this 4c0, and then 2 to the fourth power, and a to the 0, so I didn't write that up, and 4c1, and 2 to the third and a to the first, plus 4c2, 2 square, a square, plus 4c3, and then 2, oops, and here we have 2 a to the third power, and plus 4c4 and a to the fourth power. What is this equal to? This portion is equal to 1, so 2 to the fourth power is what we have. 2 to the fourth power is 16. Plus, how about here? This is 4 and then this is 8, so we end up getting 32a. Plus this becomes 4, while 4c2 becomes 6, so we get 24a squared. Here we have this is equal to 4 times 2 becomes 8, a to the third power. And then the last one. Here we have a to the fourth power. That becomes our answer. Now, number 9. I'm going to use the blue. Here we have 2b minus 1 to the third power. Then same as before, so first one is 3c0, and then 2b to the third power, plus 3c1, then 2b squared times negative 1 to the first power. The next 3c2 times 2b times negative 1 squared. The last one is 3c3 and then negative 1 to the third power. Now if you have to simplify each and every one, here we have this one is equal to 1, 3c0, and 2 to the third power becomes 8, so we have 8b to the third power, and here we get to realize it's got to be negative because of this one. And 2 squared becomes 4, times 3 becomes 12, b squared. Here we end up getting, this is 3, while this one is positive, so I'm just going to put down positive. Here we have 3 times 2 becomes 6b. Now here it becomes simply negative 1. That becomes our answer. Alright, so we are looking for, write down the nth term of each binomial expansion. Now, we can try to understand this one in two different ways. Nth term as in the where exponent of the, one of these two becomes 3, or simply the third term. Third term, in fact, of the decreasing order of exponent of x, then what's going to be happening is this. We're going to have y to the third and x to the some power. But the thing is, sum of these two exponent has to be 15, so this has to be 12. Now that means what we end up getting is binomial coefficient is 15, choose 3. That becomes our answer. Now, so then let's try to calculate 15, choose 3 here for a second. Taking out the calculator. Alright, so here we have 15 math, probability, number 3, and NCR 3. Then you get 455. So our answer becomes 455 x to the 12th power and y to the 3rd power. That becomes our third term with y being equal to 3. Now, but in fact, another way of looking at this one is this: if another person interprets this one as a third term, that means first term will have y to the 15, second term will have y to the x to the 15, and the second term will have x to the 14. Third term will have x to the 13th power. If we are looking for that, depends upon what the question defines nth term as, then we're going to have x to the 13th power and then y squared. In this case, our coefficient is 15, c2. That's basically what we end up getting. Then here, if I have to do that portion, we'll get 15 math, number 3, 2, so here we're going to have 105, so our answer would have been 105 x to the 13th power and y squared. So depending upon the interpretation of the question, if we talk about the exponent of y being 3, then the first one will be the answer. But if we are talking about simply the third term, because n is 3, then the bottom one will be our answer. Now how about this one? Why don't we try to go through this one? So the fact that we are looking at 6th term, that means first term would have been a to the 7th power, and 6, 5, 4, 3, 2. In other words, 3a squared becomes our 6th term if the first term becomes the 3a to the 7th power. And then we have 2b, therefore to add up to be 7, we have to have a 5th power. Now, then our coefficient will be 7 choose 2. If you have to get 7 choose 2, that will be equal to 21 times 9 times 32 and a squared and b to the 5th power. So let's try to multiply those numbers together. Here we have 21 times 9 times 32. There it goes. So here we have the answer becomes 6048 a squared b to the 5th power. That seems to be the 6th term in decreasing order of the exponent of a. Alright, let's move on. Using the sigma notation that can be used to find each probability. Okay, so they want us to put the sigma notation at least 10 heads. That means we're going to have 10, probability of getting 10, and then all the way up to 15. Probability of getting 15. So if you want to use the summation notation, basically we are looking at where I goes from 10 through 15 because that's the number of successes. Now, how do you calculate this one? So success will be 1/2 having the head to the i-th power. Then failure becomes the other 1 minus that to the 15 minus I power. Now then coefficient becomes 15 choose I. Now, but the thing is, these two things can be simplified because when they have two common base, we can add up the exponents. So therefore, this becomes summation of I goes from 10 through 15 of 15 binomial coefficient, which is 15ci, and then 1/2 to the 15th power. That becomes our answer. Alright, at least 5 wins. That means we are looking at 5, 6, and all the way up in the next 20 games, while probability of winning is 2/3. Okay, let's look at it. At least 5 wins, that means we are looking at 5 wins to 20 wins. Then this means our summation has to be I goes from 5 to 20. Now, binomial coefficient will be 20, choose I, and we're going to have I number of 2/3, I number of successes. That means failure, which is 1/3, has to be 20 minus I. So therefore, this becomes our answer. Alright, that's it, and I'll see you later. Bye-bye.